quickly. We won't take as much time on this one. I hope the screen is visible. Average runs scored by Virat and Rohit in the last 10 test matches that they played are respectively 55.82 and 57.73. Details of the scores are given below. Which among the two should be picked for the next test match and why? Data is given to you. It's there in the Excel sheet which I've shared with you.
So the stats for Virat looks a little more consistent comparatively.
Okay, this is you're just looking at it and telling me, or have you done any analysis?
No, I was just simultaneously doing it with you.
Oh, great. Okay, great. Yeah, it's a great observation. It's a good observation. Yes, yes, please.
So the average is probably more for Virat, and the variance is also. I mean, it's on the very low side.
Okay.
Apart from that, there's no repetitive. So 56 is the median, and yeah, I mean, then variance. It's the major criteria for me, which is less for Virat.
Right. Okay. So can I just particularly ask Deepak? I think I've heard anything from Deepak. Deepak, what are your thoughts?
Sir, I think Virat is more consistent. Mean is slightly lesser than Rohit. Median is the same. But if we see the mode is 56, the variance is roughly 1/4, a little higher than 1/4, but the standard deviation is roughly half of Rohit.
Okay.
I mean, Virat has standard deviation roughly half of Rohit.
So have you guys calculated the standard deviation?
Yeah. So standard deviation for Virat is 18.07 and for Rohit it is 34.99.
Okay.
I mean roughly 35. The first quartile for Virat is 39. For Rohit it is 26. I mean, if you look at the 5-point summary, then quartile 1 for Virat.
Just hang on one second, Deepak. I just see are you all comfortable with this 5-point summary? The whole class is comfortable?
Yes, sir. All these things have been covered in the previous courses.
Yes. Oh, okay. Oh, great. Wonderful. Fine. Fine. Great. Okay. Yes. Please go ahead. Yeah. Okay. So then, okay, if you are sure it's about consistency, tell me what is this value which measures consistency? What measures consistency?
So one way of measuring consistency can be standard deviation or variance, which can indicate how much spread the values are as compared to the mean.
Okay.
And also we can use the 5-point summary to see how spread out the values are around the median.
Okay.
So these two things can indicate how narrow the range is around the mean or the median, and the shorter the range is, more consistent it would be. I mean,
okay. Yeah. Okay, I take your point. Any other inputs? Can anyone tell me one single measure of consistency? Because he told me so many. He told me shorter the range, that's better. Shorter the standard deviation is better.
We can take coefficient of variation also as a measure.
Absolutely. Yes, Shivam said this. I would just go back to somebody else to understand what is coefficient of variation. Let's say, can I hear from Satyam? Satyam, what is coefficient of variation, please? Ankit, coefficient of variation?
Yes, sir. So the coefficient of variation is sigma by mu cross 100. That is standard deviation by mean cross 100.
Okay, sigma by mu 100. Great, wonderful. So what is sigma?
Sigma is standard deviation.
And what is mu?
Mu is mean.
What is x bar?
Okay. X bar is
mean.
Mu. Yeah.
So why do we have two notations? Why do we call it x bar? Why do we call it mu?
Sir, all the Greek letters represent the population.
So one is the population data, one is the sample
and
data.
one is the given data, sample data, one is the population data. All the Greek letters are represent population data.
Okay, which are these Greek letters?
So the mu.
Okay. So tell me the corresponding. So if mu was the Greek letter for, I'm just trying to see how much. Okay, mu is what? Mu is average, mean.
Mu is population mean.
Population mean. Okay. If mu is population mean, is there some other mean?
The sample mean would be X bar.
X bar.
X bar is sample mean and
Great.
mu is
Okay.
population mean.
Okay, great. Yes. Similarly, for let's say standard deviation, are there two different terms?
Sigma for population standard deviation and S for sample standard deviation.
Okay, great, wonderful. Okay, concepts are pretty good. Okay, fine. Okay, then let's come back to coefficient of variation. Yes, please. Please continue with coefficient of variation. Yeah, I think Ankit was telling me this. Who was telling me about coefficient of variation? What was it? Yeah.
Yes.
Sigma by mu. Okay, yeah.
Yeah.
Yeah, sigma by mu into 100. Right. Okay. So the issue with what Shivam said, I think it was Shivam who responded earlier. So because if you simply look at, like say just the range or the standard deviation, if you simply say smaller standard deviation, you cannot really compare it. Okay. To compare two sets of data, you always need to get what is called as a coefficient of variation, because you divide standard deviation divided by its mean. So sigma by mu into 100, coefficient of variation. This particular term measures consistency. Okay, so let's just look at the data there. Yeah, scenario 2. So I hope you can see this now. Can you see the average standard deviation coefficient of variation? The slide. Yes. Yeah. Okay. Great. Yeah. Yes, okay. So you have Virat scores, you have Rohit scores, and you find average. Average for Rohit is marginally higher than that of average of Virat. 57.73 for Rohit, 55.82 for Virat. However, when it comes to consistency, which is what is most sought after in test match, you want the person to score repeatedly certain high score. When it comes to that, you find that Virat is significantly more consistent. His CV or coefficient of variation is 30.9, which is obtained by dividing the standard deviation by average. That standard deviation is 17.2 for Virat Kohli, and it's significantly larger, almost double, 33.4 for Rohit Sharma. So basically, you have a much higher standard deviation, which means he is unlikely to perform consistently. But the singular measure for measuring consistency is in a data set is what is called as coefficient of variation. The smaller the coefficient of variation is, better it is when it comes to consistency. So if your standard deviation drops down to a very small number, let's say instead of 17.2, it is 1.72. So your coefficient of variation is also going to become 3.09. Right? Either, if the standard deviation becomes 0, then it becomes, the data, of course, there is no variation. Right? But briefly, could someone tell me what standard deviation is and what its relevance? Before I move to the next example.
So standard deviation is a statistical measure that quantifies the dispersion of scores around the average.
Okay, what are the other scores which quantify this? Measures of dispersion. We talked about measures of central tendency earlier, mean, median, mode. Okay, now what are these measures of dispersion?
Range.
Range
is one, yeah.
Range is one. Great. What is range?
So maximum minus
range
minimum.
Is difference of maximum.
Yeah, maximum in that distribution divided by minimum. That's the range. Okay.
Then variance with and square root of variance as standard deviation.
Okay, variance and square root of variance is standard deviation. Okay.
So coefficient of variance is also, I guess.
Coefficient of variance, not quite, but okay, yeah. And one more, I think.
Interquartile range.
IQR, absolutely. Interquartile range.
Yeah.
Absolutely. Okay, difference between quarter 3 and quarter 1. Q3 minus Q1 gives you IQR. These are the measures of dispersion. And quickly, what is the variance again? Can someone tell me what variance is?
So it is the sum of squares of the deviation of each value around the mean.
Sum of square deviation?
No. I am trying to say we take that.
I know what you're saying, but did you say it right?
Average squared deviation from mean.
Average square deviation, exactly. And can someone tell me why is it that, why don't you take average deviation? Why are you taking, why are you squaring it? Why average square deviation? Why not average deviation?
To minimize the residual.
Yes, Sayan, please, louder, please.
To minimize the residual.
You're not audible. Could you please, yeah.
To minimize the residual.
Minimize the residual. Yeah, anybody else wants to pitch in?
So it penalizes the I would say the negative deviation more. Or in other words, if it is deviating a lot from the middle point, then then it's more reflective of that phenomenon.
Sir, we square.
It reflects
we take the difference and yeah, go ahead. Shivam.
Yeah, go ahead, Shivam. Yeah.
Sir, it reflects the relative weight of each deviation. That's why.
Not really. I think all of you have some idea, but I just want, yeah.
We take the difference and then square it so that the negatives and the positives do not cancel each other out. One is that, and the second is that.
No, that is only reason. Deepak, that is only reason. If you don't square it, the positives and the negatives, the deviations cancel each other out, and then you can't get an average of it. If you see, you said it's the average of squared deviation. If you don't square it, if you try to find the average of deviation, it will just get reduced to 0 because all the positives will cancel out all the negatives. Because by definition, your average is the value which is situated right in the middle. You sum up all the value divided by the number of observations. Now, if you don't square your deviation, if you simply take the deviation and try to find the average, it gets reduced to 0. Correct? The positives cancel out the negatives. So in order to obviate this, you square it so that the negatives don't cancel out the positives. And then you divide it by the number of observations. That is why the variance is mean of squared deviations. Right? Yeah. But because variance, because you have squared it, you want to bring it back to its original comparable measure. That's why you find square root of that, and that's how you get square root of the variance. It's your standard deviation.
So, sir, we want to eliminate the negative values.
Not eliminate. What? See, what did Deepak say? Deepak said variance is average of squared deviations, which I agree with. Okay. And I posed him a question, why are you finding average of squared deviations? Why are you not finding average of deviations? To which none of you gave me a satisfactory answer. And I'm trying to answer that. The reason why you're having to square the deviation is because if you don't square, and if you simply try to find the average, then the positive deviations and the negative deviations will cancel each other out in every single data set. You take any data set and try to find the deviation, and try to find the average. All the positives and all the negatives will just cancel out, and sum of that is going to be 0. So to make sure it doesn't get cancelled out rather, so you square it. Okay, that is why it is average of squared deviations, not average of deviations. So average of squared deviations is your variance, and then square root of its value is your standard deviation. Because I think I was given to understand, who told me now? Somebody just told me that you've been taught these things in the previous session. So I was just like I said, I was just trying to assess how much you already know. Is it clear, Amitav? Is it not understood? Or is it still confusing?
No, sir, understood.
Okay, clear. Okay, great. So yes, please. Yeah.
So one question I had was regarding the standard deviation here, 17.2 and 33.4.
Okay.
So, should this be based on formula for population variance or the formula for sample variance?
In this particular, it's a good question that you asked me. Okay, fine. What do you think we should be taking?
Sir, ideally it should be. I think it should be based on sample standard deviation formula, which is divided by n-1. Because we have taken a sample of observations out of so many innings that Virat and Rohit might have played. Okay,
right. Yeah, absolutely. It depends on how you treat the data. Suppose you say that this is the data on which, this is the population. If you say that, my analysis is completely based on this, then you take the population formula. However, like you rightly said, if you say these are indicative scores and treat this as a sample of whatever is going to happen, like say for instance, Virat has had a long 10-year innings and this is just 10 test matches. So I would try to treat this as a sample. Okay, in which case, then you use the formula for sample.
All right. So it depends on the context of the data.
Exactly. Now, let's say, for instance, if I, there are like 16 of you in this class. Now, if I find your average, age or scores or weight or whatever, and if I say this is the average of, because of course it doesn't apply to average because the formula is same for both for population and for the sample. However, if I have to find the standard deviation. Now, it depends on whether my interest of study is only 16 of you. But however, if I'm using this study, let's say small sample of 16 of you to study something larger, if I find some result out of this, and if I have to extrapolate it onto a larger, let's say sample, if I say that no, based on the study I undertook on 16 students who registered for the e-masters program, I found the average standard deviation of their, let's say, scores to be this. And therefore, it's likely to be the same for a larger population out there. If I have to make that deduction, if I have to make that inference, then I have to treat this as a sample and then apply the formulas for sample. However, if I'm only interested in talking about the 16 students, I want to know, how good, let's say, for instance, if I conduct a test and I want to say, okay, this is the average, this is the standard deviation, and if I treat your group of 16 as a population, then the formula for the population applies. It depends on what it is that you're trying to do with your research or with your study or whatever.
Sure, sir. Sure. Right.
Yeah, right. Say for instance, okay, I give you a different example. Now, if I study all the entire population of, let's say, Bombay, the population of Bombay, there are 2 crore people there, and then I sort of make some study. And if I'm using the thing only for, let's say, whatever findings I find, if I'm only going to apply it to population of Bombay, then I can, of course, use the population for that. However, if I'm using Bombay as a proxy for the other metros in the country, if I say that, okay, I've done the study in Bombay, and it also applies to Madras and Bangalore and Calcutta, then, of course, you have to use the formula for sample because you're choosing that 2 crore population as a sample for the wider population of, let's say, 140 crore in the country. Did it confuse you, or I hope, is it okay?
No, sir, that's correct. But in that example of population of Bombay with n of 2 crore, it would not matter really whether we use n or n minus 1.
It won't matter, but conceptually you should know why something is done. Correct. I was only testing your concepts. I mean, this session, whatever last 1 hour, I've only been testing how much you already know. Correct. Because I need to, like I said, when I looked at the Excel sheet, I wasn't sure. Okay. But anyways, yeah. Right. Okay. Now let's just move forward. So all of you know average, standard deviation, coefficient of variation. Great. Okay. Now, okay. Essentially, so therefore, analytics is nothing but collection and usage of data to generate insights, and which helps us make better decisions, essentially. Right. So when you look at the data prima facie, you will perhaps likely think about one sort of outcome, or you will have a certain idea in mind. But let's say when you look at data deeper and you drill down deeper, very likely you might likely to end up with different insight. Okay, so broadly you have descriptive analytics, predictive analytics, and prescriptive. Could someone help me with these? What is descriptive analytics? What is predictive? Yeah. Okay. Right. Okay. But I'm just trying to see if you already know it, because because a lot of those things I understand you're let's say conceptually your statistics.
One more question, sir.
Yes, please.
So why are they pushing Python so much for data analytics, sir? Most of the companies use Python for data analytics and not any other kind of software. Like
no, I have no reason why, because if, for instance, SPSS is especially for a researcher, SPSS is the most widely sought after thing. Now, if there is a particular reason, I personally haven't used Python all that much, but there could be some inherent advantage that particular software is offering. But I intend to do it largely because it is largely a corporate audience. I intend to do this on Excel because this is one of the most widely and simple, easily understood softwares. So I don't want to sort of stress you with too much of coding and all of that stuff. But of course, there are people who vouch for MATLAB. There are people who vouch for SPSS. There are people who are comfortable with R. And at the base of all this is basically statistics. Okay, it is understanding of statistics, which is further explained using all of this software. Okay, right. Okay, now Could somebody help me with what is this? What do you understand by descriptive analytics?
Descriptive analytics is about summarize. Sorry, go ahead.
Hang on, I think 1 second. Are we overshooting time here? It's 3:30.
Yes, sir, we are overshooting time.
Oh, please, okay, please let me know this. I mean, oh goodness, I'm so sorry. Okay, now let's quickly make this decision. What time do we meet tomorrow? I think Aditya had an issue. Aditya?